Okay, so let's scoot on. We're going to learn how to build linear models from data. First, we're going to start with scatter diagrams. And you're like, well, what's a scatter diagram? So here's the deal. Suppose somebody is conducting an experiment and they have all these results and they hand it to you, the number cruncher, and say, what do I get with all this? Well, you plot it, and your plot looks something like this. You plotted all the points and you've got this shape, and you're like, this shape looks familiar. Is it linear? No, but it does have a relationship, and it almost looks like a parabola. Not a perfect parabola because some places are wider than other places, but it looks like a parabola, doesn't it? So you would go back to them and say that there is a relationship, but there is a non-linear relationship. Does that make sense? Good. Let's look at another one. So now they've given you these data points and you've plotted them, and this is what you get. And you're like, well, this is really interesting looking. Does this look like anything? Well, it looks like something to me. It actually looks like a very thick line. He's like, I don't see it. Well, pretend you've got this big expo marker and you just took it and you just made one line. Looks like a line, doesn't it? It's a thick one, but it's still a line. Yes? So there is a relationship. There is a linear relationship going on here. Now, mind you, there can be instances where there's no relationship, so keep that in mind. Okay? But these last two examples had some kind of relationship. These points had some kind of relationship with each other. These are scatter diagrams. Cool? Okay, let's scoot on. So they're giving us this data, and they would like us to do a few things. First off, the first question they have for us is to give them an equation of a line that's using the first and the last data point only. Now, if you take a look, you're asking yourself, well, is this really a linear relationship? Well, the x's are okay because the x's are constant. They're increasing by 1, right? They're consistent, I should say, not constant. They're consistent. They increase by 1. The y's, however, are not as consistent. But if we plot them, and we shall plot them, we'll create a scatter diagram, you'll see that it almost creates that line that we're looking for. But for now, let's look at actually coming up with an equation of a line. So I am going to get myself some paper over here to work with, and the points we were working with were 3, 4, and 9, 16. So here's the thing. Remember, when you're coming up with an equation of a line, the first thing you need is the slope, right? And you have to remember, slope is the difference of the y's over the difference of the x's. Well, as we get sophisticated, we say the change in y over the change in x. That little triangle is called delta, and yes, it's a Greek letter. So we have the change in y over the change in the x's. So, but it's the slope formula still, regardless. You with me? Okay, so as I'm doing my work, hopefully you're doing your work, and you end up with the slope being 2. Did you get the same answer? Good, so did I, clearly. Now, once we have that slope, now we need to come up with the y-intercept, don't we? Well, or we could come up with the whole equation at the same time. And if you remember, there is an equation called slope point form. And the reason why it's called slope point form is because you need a slope, we have it too, and you need a point. Now we have 2 points. Do you think it much matters, or it matters which point we use? No, why should it? Because both points are supposed to be on the same line. It's your choice, whichever one you want to use. I'm going to use the 0.34. Why? Because they're smaller numbers. Some of you use the 0.96. You'll see we come up with the same exact equation. So something that I want you to know is that the point slope formula is a rearrangement of the slope formula. We didn't pull this out of the thin blue air. And if you're like, how is that? Well, if you recall, the slope formula looks like this, doesn't it? Difference of the y's over the difference of the x's. And all we did is multiply both sides by the denominator, which is how we actually get the point slope formula. So just a heads up on that. I promise we didn't do anything funny to get this equation. So let's start plugging things in. We have y minus our y1, which in this case is 4, equal to 2 times x minus x1, which is 3. And as I do my work, hopefully you're following along with me. And if you use the other point, I'm sure you're getting the same answer I'm getting. Cool? Does this make sense? Loving it. Okay, so that's part A. They asked us to come up with an equation of a line. We did, 2x minus 2. Now, part B is going to ask us to come up with the line of best fit. Now, here's something you need to understand. We came up with this equation by only using the first and the last data point. What happened to all the other points in the middle? We know that the change in the y is not consistent, so we don't have that perfect line. So we need to take into account all the other points in the middle in order to come up with the accurate equation of a line. So when they ask us to find the line of best fit, they're asking us to use every single data point. Well, the way we do that is we need our graphing calculator. So you go get yours and I'll get mine. So here's my calculator. I need to turn it on. Okay, so now here's the thing. We need to input all our data in order to come up with the line of best fit. So I need to go back to where my data is. I need to get my calculator again, so forgive me. There we go. Now, to input the data, and I'm going to erase these little circles so it's easier. To input the data, we need to use this stat key. So when you hit the stat key, it has 3 titles to it: edit, calc, and tests. So we need to input the data. So we're going to do some editing. Now, before we actually do some editing, we need to actually make sure our lists are cleared out, because you may actually have data already in those lists. So we need to get rid of that data. By the way, this calculator can have like 10 different lists. We only need 2. So do you see in my calculator, item number 4, it says clear list. So I'm going to hit number 4 to clear the list. And it's asking me, well, which list do you want to clear? Because it's saying I'll clear it, but you have to tell me what you want me to clear. So do you notice above the number 1 key, there's L1, and above the number 2 key, there's L2? Those are the 2 lists I'm going to use. I'm going to use one of them for X and one of them for Y. But since they're written in yellow, I need to use my second function key to get there. By the way, I'm hoping you're taking notes and writing this stuff down if you're not familiar with how to do this. So I'm going to hit second function 1. And I have to hit a comma in between. If I don't hit the comma, it's not going to recognize L1, L2. It needs to have a comma in between the 2 lists you want to clear. So once I do that, I'm going to hit enter, and it says done, which means my lists are cleared. So now I'm going to go back to stat, and I am going to now just hit number 1 because I want to edit my lists. So my first list will be the X's, the input. My second list will be the output, the Y's. So we have to make certain that we are careful on our inputting because we can miss a number. So You start inputting your x's and I'll start inputting mine. Okay, so according to the count, if you notice there's a count down there, I stopped at 7. So I'm going to scoot over to the next column and I am going to start inputting my y's. Okay, so gratefully I ended up with 7 in each column. Because if one column has more than another, it's going to give you a dimension error. So be very careful about that. Okay, so inputted my x's and my y's. And now I need to go back to stat. And I need to tell the calculator to compute. I need to tell the calculator to calculate. So I'm going to scoot over to the calculate column. And I need to tell it to compute the line of best fit. Well, in the calculator, it's not called that. In the calculator, it's called linear regression. Do you see item number 4? That's linear regression. That's the line of best fit. And do you notice next to it in parentheses, it has that ax plus b? Yeah, it looks like the y equals mx plus b model, doesn't it? Okay, so I'm going to hit number 4. And it's going, great. You want me to compute this line of best fit, this linear regression. Which lists do you want me to use? Well, I have to tell it which list to use, because if I don't tell it which list to use, it doesn't know what to use. So L1, right? And you got to put a comma. Those are my x's. And then L2, and then I hit enter. And hopefully you've come up with the same numbers I have. So I would like us to round to 3 decimal places. So my A is 2.036 and my B is negative 2.357. Good? Okay, so I am going to scoot over and I am going to write that down. So my line of best fit was y equals 2.036x minus 2.357. Now, we weren't too far off, were we? Because if you look at this line that we got by hand and you look at the one the calculator got, the numbers aren't too far off, so that's a good thing. Now, another question they could ask you to do is to actually create a scatter diagram. So, and then once you create the scatter diagram, it could actually ask you to graph the equation from part A with the points, or it could ask you to graph the equation from part B with the points also. So be aware of that, all right? Okay, so I need my calculator back. You, I'm sure, still have yours in your hand. I'm working on getting mine again, so hang in there. Okay, so here's my calculator. Now, if I had some of the choices, they would normally give you choices of which scatter diagram was the correct answer. And they would give you the windows to work with. Well, here's the deal. I'm going to give you the windows I want us to work with. So let's go to the window key. Do you notice it's set up at -10 on the x min and x max is +10? Well, considering my smallest x was 3 and my largest x was 9, I'm okay with the x max, but the x min, I don't need it to go all the way to -10, so I'm just going to start it at 0. And then, do you notice, and the scale of 1, that's just fine. Also, if I scroll down to the y min, the y min is -10. I don't need it to start at -10. My first y was 4, so I am going to put in 0 for my y min. Now my Y max, on the other hand, that was 16, wasn't it? So I could actually have this end at 20. But I don't want the scale to be ones. I want the scale to be 2. Okay? All right, so now here's the thing. I can't just hit graph because I'm not graphing a line. I'm graphing points. So I need to create a scatter diagram. I need to create a stat plot, as it's called. And above this Y equals key, it says stat plot. So I am going to hit second function to get to it. And all my scatter diagrams, or stat plots, they're all off. So I'm just going to go to number 1, and I'm going to turn it on. And the type is the points. We're fine there. My X list is L1. My Y list is L2. Those are defaults. That's great. And marks are these little squares. I'm okay with that too. So I'm just going to go hit graph. And there are my points. Do yours match up? Good. Now, that was part C, create the scatter diagram. We did it. Now, part D says graph the equation from part A with the points. So remember, you have to go to the Y equals 2 key, and I'm going to hit 2x minus 2. And then I'm going to hit graph. And there is the Y equals 2x minus 2 line graphed with my points. Cool? Hopefully yours looks like mine. And now I'm going to go back in because they said graph the line from part B, which was the line of best fit. So we have 2.036x minus, remember to hit the minus key, not that negative key down there. Otherwise your calculator is not going to function properly. Okay, and then I'm going to hit graph again. And this is what that line looks like. Remember, those lines were pretty close. So, and if you actually have one of the newer calculators with colors on them, you could actually put both of these equations in, and you could see the difference between where the lines are hitting those points. They're probably pretty close to each other, I would say. Good? Okay, let's look at another one. So, for the data given below, they would like us to first off find an equation of a line containing the first data point and the last data point. So, I am going to get myself a clean sheet of paper so I can work, and we are going to do that. So my points were negative 21, 101, and negative 11, 141. So again, first we need the slope. So we have the change in y's over the change in the x's. So that double negative makes it an addition problem, doesn't it? Okay, so it looks like I have negative 40 on top and a negative 10 on the bottom, which tells me my slope is 4. And I want to come up with the actual equation now. So remember, I'm going to use the point slope or slope point form, which means I need a point and a slope. Well, the slope I have. The point, your choice which one to use. I'm just going to use the second one, negative 11, 141. And you're like, why are you using that one? Just felt like it. Trust me, you're going to get the same answer either way. Some of you may have used the first point. That's totally fine. So remember, it's always a good idea to write the form or formula down so you know exactly where numbers are going. This is what it is looking like for me. Some of you may use the other one. That's great. If you did, keep using it, and this makes it an addition problem. Oh, look what I forgot to put in. I forgot to put my slope in. Okay, did you come up with the same thing I did? Wonderful. Okay, Okay, so part B is going to be asking us to find the line of best fit. And part C is going to ask us to come up with the scatter diagram. And part D wants us to graph. So we'll be able to graph one of those equations with the points, okay? So I need to get back to the points so I can see them. And I also need to get my calculator out. So you get yours, I'll get mine. Power off. Auxiliary mode. Okay, so here we are. I need to input this data, so I need to clear my lists out. Let me quit out of here first. Let me clear this screen off. That's just me. I just want to clear it off. And that's right. We need to go to Stat. We need to go to number 4 to clear the lists. And let's see if you follow along with how I'm doing this. Hopefully you wrote yourself some notes. And if you didn't, hopefully you're writing yourself some notes now. Okay, my lists are cleared. Now it's time to do some inputting. So you input your X's and Y's, I'll input my X's and Y's, and hopefully we end up with the same scatter diagram. Remember, the negative key is down here. And sorry for you guys hearing all the tapping. I don't know how to not make the tapping be there. But hey, at least you get to see what I'm doing on the calculator, right? Okay, those guys are inputted. Okay, all my points are inputted. Now, let's see what we're going to use for our window. Because notice our x's go from a -11 to a -21, right? Okay, so maybe we can have our x's start. And again, they will tell you this information. I'm just going to give this to you right now. Maybe we can have our x's start at a -10. And I don't need them to go to +10, do I? So actually, I need to go do the other way around. The smallest x I want is like a -25, and the largest x could be the -10. Okay, increments of 1, I don't think so. Maybe we'll just do increments of 2. Okay, let's go to those y's. Y min, well, the smallest y min is 101, so I think we'll just do 100 as this y min. And my y max, we could do it 150. And I don't want those in increments of 2. How about we say increments of 10? Okay, so let's go. Wait a minute. I can't graph it yet, can I? And some of you may be thinking, why not? Remember, we have this y equals in here. And this equation didn't go with this problem. It went with the last problem. So I need to clear this out before I do my stat plot. Well, that's an interesting stat plot, don't you think? Okay, now I can take one of those two lines that I had gotten before, and I can go ahead and create the line with the points on the plot. So I am just going to hit the first one we got, 4x plus 185. And that's what that looks like. I missed a few points, didn't I? Yeah, we certainly did. Okay. You know the one thing we didn't answer? My fault. I took it a little out of order. But that's okay. You see what's going on. So right now I graph the points with the equation, the 4x plus 185 that we got, which was the line we got by hand. What I didn't find was the line of best fit. So let's go find it. Do you remember how to find it? Okay, that's right. Go to Stat, go to Calc. That's right. Go to number 4, and you have to tell it which lists to use. And enter. And not too bad. We have, and let's again round to 3 decimal places, 3.861 and 185.153, right? Okay, you know, I'm going to try a little experiment here. So that's the original one we got, right? So, and if you have a newer calculator that's actually got color, you're going to be able to see this a little better than we're going to be able to see it on mine. All right? But I'm going to try this, and I'm going to see what we can see. There's the new line. So the new line falls a little bit more in between all the points versus the line on the bottom, which was the original one we got by hand. Cool? Okay, getting the idea? Good. So let's go to another problem. We did this. Oh, let's put the line of best fit in so we have that answer. Because the other two answers are basically calculator answers, right? Okay, there we go. Cool? All right. So let's look at this last problem. We have this data representing the weight in grams of various candy bars. Now here's the thing. There's 10 candy bars, and this is a continuation right here. They didn't stack it one on top of the other. Why? It would have taken up too much room. Okay, so let's take a look at this information. We have weight and we have calories, and they were nice to us. They told us which was the input and which was the output. But you know, let's make sense of this. What depends on what? Does the weight of the candy bar depend on the number of calories are in the candy bar? Or do the number of calories in the candy bar depend on the actual weight of the candy bar? Good, that's correct. The calories depend on the weight, which is why the calories are the Y's and the weights are the X's. So first thing they wanted to do is create that scatter diagram. Okay, I need my calculator. I'm sure you still have yours in your hand. Mine I have to go get. It might help if I don't double tap. I'm so used to double tapping, right? There we go. All right, so first things first. I am going to clear stuff out. Okay? And I need to clear out my list, don't I? So let's see about you following along with me. Let's see, clear list is item number 4. And I need to clear the first list, comma, the second list, and enter, and they're done. Now I am going to start inputting my lists, so we're going to edit. And I'm going to move my calculator to the other side and start inputting my X's and my Y's. So you input yours, I'll input mine, and then we'll take it from there. You might want to put your computer on mute for a little bit because you're going to hear me doing all this tapping. I'm probably not going to be saying anything, just so you know, so you won't be missing anything. Okay, so gratefully I have 10 numbers in each column. Now, they want us to create the scatter diagram. You can look at any one of these graphs down here and notice the windows are all the same. So let's take a look at the windows. The X windows look like they go from 40 to 70. Now, in terms of the scale, look how many tick marks are in between. 1, 2, 3, 4, 5, 6. So I have 6 tick marks over a distance of 30 spaces. Yep, each tick mark is a space of 5. Looks like the Y min is at 380. And it looks like the Y max is at 490. And let's see the scale. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in between. 110 spaces. Yeah, 10 is good. Okay, so let's graph. That's what my graph looks like. Does your graph look the same? Okay, let me move my calculator over. So which one of these graphs, A, B, C, or D, actually look like what we got? Yeah, D. And then they can ask us to do the line of best fit. They can ask us to graph them. They can actually, once we have the equation, they can say, hey, okay, so if a candy bar weighs, 53.2 grams, how many calories is in it? Well, that's easy to find once you have the equation, right? You just plug it in. Good? Okay, so hopefully this makes some sense to you and you get a better idea of how to use your calculator. You have fun with this stuff, and I'll catch you on the flip side.